Okay, we're going to talk about solubility curves in this video. Now you're going to need a picture of a solubility curve, and you should have one in order to follow along with this video. Now before I get to example problems, I want to describe the solubility curve a little bit. I want you to notice the what each of the axes are labeled. If you look at our y-axis, it says grams of solute per 100 grams of water. This axis is telling us that the numbers represent the amount of solute that is able to dissolve in 100 grams of water. We usually think about water in terms of volume, so 100 grams is the same thing as 100 milliliters of water. If we look at our x-axis, we see that it is labeled temperature in degrees Celsius, so we are figuring out the temperature of the solution. Now you see some lines, some solubility curves that are going up. All of those ones that are going up from left to right, those are of solid solutes. They have a positive heat of solution, meaning that the slope is going to be positive. If you look at all these solubility curves that are going down, so down from left to right, those are all gases, telling us that as temperature increases, gases actually become less soluble. That is known as a negative heat of solution and is exothermic. If we look at each of these lines, there's a lot of information that we can figure out. Let's take the NaNO3 line for example. If you are right on the curve, that is the saturation point, meaning that that is the maximum amount of solute that can be dissolved into the solution at the specific temperature. Now, if we are above the line, it's telling us that it is a supersaturated solution, which means there's actually more than the maximum amount of solute that can fit into the solution at that specific temperature. If we are below the line, it is telling us that it is an unsaturated solution, and we can input even more solute into the solution and it will dissolve completely. Now I'm going to move this graph away, but make sure you have a copy of this on the side while we go through the practice problems that you need to understand. So the first example problem I have here says how much KNO3 will dissolve at 70 degrees Celsius. The way you're going to do this is you're going to go to 70 degrees Celsius on your solubility curve and go all the way up till you find KNO3. The point at which you intersect the line at KNO3 is the saturation line. That is the most amount that will dissolve in KNO3 at 70 degrees Celsius. So all you need to do is read how many grams of solute will dissolve, and that answer right there is going to be 130 grams. Number 2 says how much NH4Cl will dissolve at 90 degrees Celsius. So same process here, you're going to go to 90 degrees Celsius, go up to NH4Cl, so the point where 90 degrees and the saturation line of NH4Cl intersect, and find at how many grams are at that point. And here we have 70 grams can dissolve. The next question says, which of the following is most soluble at 15 degrees Celsius? So most soluble tells us that a lot of solute is able to dissolve in the solvent. So the higher up we go on our solubility curve, the more soluble that solute is at that specific temperature. So if we're talking about the most soluble, we're talking about the solubility curve that is highest up. If we're talking about the least soluble, which means that it will not the solvent will not take in a lot of solute, we're looking for the lowest curve. So we want to know between KNO3, NaCl, and NH4Cl. So you're going to look at your solubility curve and figure out at 15 degrees Celsius which one is going to be lowest. So if you go up, the first one that I'm pretty sure you hit at 15 degrees Celsius is going to be KNO3. let's just make sure that I have all my lines straight. I'm sorry, this is most soluble. I am confusing you and I apologize. Most soluble means that it's highest up. So KNO3 would be least soluble. So the most soluble one is going to be NaCl. At 15 degrees Celsius, NaCl has the most amount of solute that can be dissolved into the solution. Number 4 says, how would you describe the solution of 70 grams NaNO3 at 30 degrees Celsius in 100 grams of water? So what you're going to do is you're going to go to 30 degrees Celsius on your solubility curve, and then go over to 70 grams. You're going to make a little dot right there. Now, they want us to describe the solution of NaNO3. So look about the dot that you made at the intersection point of 30 degrees Celsius and 70 grams, and see where it is in relation to the NaNO3 curve. If it is below the line, it's unsaturated. If it's on the line, it's saturated. If it's above the line, it's supersaturated. The 30-70 intersection point is going to be below the NaNO3 saturation line, so that means that it is unsaturated. Okay, number 5 says, how many grams of KClO3 will dissolve in 300 grams of water at 50 degrees Celsius? Now, this says in 300 grams of water, but if you look, our solubility curve only says 100 grams of water. But for this problem, we can set up a proportion. So we want to know how many grams will dissolve, so that is at the saturation point. So what you're going to do is you're going to go to 50 degrees Celsius and see how much can dissolve in 100 grams of water. So you're going to go to KClO3, and it looks to me that it intersects at 20 grams. So we have 20 grams that will dissolve in 100 grams of water. We want to know how many grams will dissolve in 300 grams of water. So it's a proportion, and when you complete that proportion, you should get 60 grams of KClO3. We look here, 300 grams is triple the amount of 100 grams, so it makes sense to multiply the amount of grams you have by 3 as well. The last problem I have here says, if a KCl solution is saturated at 80 degrees Celsius and cooled to 30 degrees Celsius, how much solute will be precipitated out? So what you should do is you should go to 80 degrees Celsius and go up to your saturation line of KCl and make a little dot. Then what you're going to do is you're going to go to 30 degrees Celsius and find the saturation line for KCl and make a little dot. When we are cooling down a solution, and if it is an endothermic reaction, an endothermic process, when you cool it down, solute is going to be precipitated out because the solution can no longer hold the same amount of solute. So if you cool it down, you want to know how much is being released. So what you want to do is subtract the grams at 80 degrees Celsius and subtract off the grams at 30 degrees Celsius, and that will tell you how much is precipitated out. So if I go to 80 degrees Celsius at KCl, make a little dot, then go to 30 degrees Celsius at KCl and make a little dot. To me, it looks like at 80, it's at 50 grams that can be dissolved, and at 30, it looks like about 35 grams that can be dissolved, so your difference there is going to be about 15 grams.